So this question says in triangle JKL, cosine of K is equal to 24 over 51, and angle J is a right angle. So I'm going to draw a right triangle. So again, strategy-wise, this is called plug-in picture. I know that I have triangle JKL, and I know that J is the right angle. So I'm going to say J here, and then K there, and then L there. I also know that the cosine of K is 24 over 51. Anytime I see cosine or sine or tangent, I'm thinking of this acronym SOHCAHTOA, which hopefully looks familiar to you. The cosine is here. The A and the H represents the adjacent side of the angle divided by the hypotenuse. That's the ratio. That's where these numbers come from. So I use that to fill in my right triangle. So I know in respect to K, the adjacent side is 24, and that would be here. And the hypotenuse is 51. That would be there. The question goes on to say, what is the value of the cosine of L? Well, for L, the adjacent side would be here, x. The hypotenuse will still be 51. So no, cosine of L should equal x over 51. So I do need to figure out what x is. So how do I do that? I am going to use Pythagorean theorem, which tells me that 24 squared plus x squared should equal 51 squared. Go straight to my calculator. And 24 squared is 576 plus x squared equals 51 squared is 2,601. If I subtract 576 from both sides, I get that x squared is equal to 2,025. If I then square root both sides, I get that x is equal to 45. So that means this side here is 45. And that means this ratio is actually 45 over 51. Can I reduce that? I'm pretty sure I can, right? So let's see. 3 goes into 45 15 times. And 3 goes into 51 17 times. So my answer here would actually be 15 over 17.